So in the valency chart, you will be given a series of basic radicals and a series of acid radicals. First, before we can use that chart, we need to learn few things. First of all, we need to learn what is this valency that we are talking about. Then there is term called the basic radical. And then there is the term called the acid radical. We will make use of them from the chart, but first of all we need to understand what these things are. Now valency, you might have studied in the first term, because first term we had the chapter structure of atom. In that somewhat we touched upon valency. Let's elaborate on the topic valency first. Now to understand valency, first of all we need to go back to the structure of the atom. Okay, we need to go back to the structure of the atom. You remember some elements, as we are already discussing many elements here. Say an element called nitrogen, a random element picked from the elements which you already know. In order to understand the concept of valency, in the first term chapter that we have discussed some charts. Remember, towards the end we had discussed some charts. Those charts had the atomic number and the mass number. You have to go back to that, chapter 4. Okay, chapter 4. Remember those charts? There are drawings, so the atomic structures. The page number I cannot remember right now actually, but I'll tell you. You can find it out on your own also. Now that valency chart, that chart was about atomic number and mass number, amongst other things. So to understand the concept of valency, which is there in that chapter also, we must understand first of all atomic number and mass number. So let me revise that, because you might have forgotten. So atomic number is basically what? The number of protons. Number of protons in an atom. If you remember the atoms, the structure of atom, which you have done in 6 also, I think, 7 also, and here in 8 also. This is the nucleus surrounded by shells. In the nucleus, we have got 2 subatomic particles, protons and neutrons. Okay. Let me just write it here, P and N, and this is the nucleus. So protons and neutrons here. Surrounding the nucleus, there is the 3rd subatomic particle, the electrons, right? The electrons are revolving around the nucleus. This is already known information to you, right? You have known this before, and you have known this in the first term as well. We have discussed this, right? So getting back to this, why am I getting back to this? Because to understand the concept of valency, you need to recall those concepts. So the atomic number is basically the number of protons, okay? The number of protons in the nucleus. It is also equal to the number of electrons. It is also equal to the number of electrons. Now, every element wants to have either an octet or a duplet. What does that mean? Well, it wants to have either 2, duplet means 2 electrons in the outermost shell, or 8 electrons in the outermost shell. So for example, we say, let's take the example of lithium. Okay, now lithium has atomic number 3. Now this atomic number mass number thing is the most important thing that will be discussed in class 8 for you for the future, because in class 9 and 10 you require it very much. You cannot proceed further without knowing this. So you must learn the atomic number and the mass number in your chapter 4, structure of atom. Okay, but we are using it here in chapter 3 also. Okay, because we need to understand that concept. So lithium has atomic number 3. So little bit let me talk about the rules of electron arrangement also. It is called electronic configuration. This lithium will be arranged in such a way. See, lithium, this number 3 means lithium has 3 protons. It also has 3 electrons. Let's be clear about that first of all. Whenever we say atomic number is 3, that you will memorize from the chart, we mean to say that it has 3 protons and 3 electrons, okay? And you know there is another subatomic particle, neutron. But neutron we do not require for the concept of valency. We just need to remember the atomic number, okay? Neutron is there, but I'm not talking about it right now. So in the nucleus there is proton and neutron. Fine? Proton is 3, neutron we don't need to know right now, and electron is 3. Fine? This much is clear. And when we draw the shells, we cannot give all the 3 electrons to the first shell. There is a rule. First shell we can give only 2 electrons. Remember this rule, okay? Remember this rule. The rule is called 2n square rule. The rule is called 2n square rule. I'm recalling this all again because it was supposed to be in the first term. I do not know how much you have completed in the first term. Some we have completed, of course. Rest was given as task. So I'm just recalling this 2n square, okay? 2n square. This is the rule. So the first shell, n means 1. In the first shell, n means 1. So 2 into 1 square is 2. 2 into 1 square is 2. In the second shell, n would mean 2. So 2 into 2 square. That means what? 2 into 4, that means 8. Okay? So you have to remember this, that the first shell can only have 2 electrons. The second shell can have 8 electrons. So in case of our lithium here, we have got 3 electrons in total. So if I draw like this, there will be 2 in the first and 1 more in the second shell, because we've got 3, so we can give only 2 in the first, and the last one we are giving 1. But as I just mentioned a while ago, that every element or atom wants to have, either a duplet or an octet, whichever is easier actually, So you can see here, if lithium wants to have 8 electrons in the outermost shell, it would need 7 more. But if it wants to have 2 in the outermost shell, the first shell can have only how much? 2. So if it has 2 in the first shell, it is completely filled to the capacity, and that time it is stable. We will call it stable electronic configuration. Okay? So in order to have 2, it can lose 1. In order to have a duplet, it can lose 1, which is much easier than trying to gain 7. So it opts to do that. Basically it does what? It loses 1 electron. Okay? So if it loses 1 electron, it will have how many? 2 in the last shell, which is its first shell also. If it loses, what will happen? This shell is gone. It will have only the first shell. Okay, it will have only the first shell, and it will have 2 in the first shell, which is the maximum capacity of the first shell, as you can see, according to the 2n square rule. Since it has lost 1 electron, we'll give a plus, indicating the electron is lost. Remember, electrons themselves are negative. So when an atom loses an electron, it becomes plus. It gets a plus charge. Okay, and this is called a basic radical. And the number of electrons it lost is called its valency. When it loses, the number of electrons lost is called its valency. Okay, it's called its valency. And after losing, what it has become now is an ion. It's an ion. When an atom loses or gains electrons, it becomes an ion. We can no longer call it an atom. And since it has a positive charge, we can call it a cation. We can also call it a basic radical. These terms, you have to be clear with these terms. So let me repeat one more time. What has happened here? Lithium has lost one electron. Okay. Why lost one electron? Because all elements, all atoms, okay, of each element want to have actually either a duplet or an octet. Now here lithium had 3. If it loses, which it can lose more easily, one electron it can lose easily, so it will have a duplet, and so it loses one electron, and hence we have a plus. If it loses one electron, plus. If it loses 2 electron, 2 plus, like that, 3 plus. As many it loses, it will that many plus you will get here. Okay, so and this becomes a basic radical. Now, and the number it lost, remember here it lost only 1, is the valency. Let's show few more examples, it will be clear. Let's take the example of, say, sodium. Okay, sodium is having 11. 11 is the atomic number. Again, you have to memorize the atomic numbers. That means 11 protons, 11 electrons. Also there are neutrons, which we are not talking about now. Protons and neutrons are there in the nucleus. Then we will draw the first shell. See, the 2n square rule is still written here. First shell we can give how many? We can give only 2. So we are giving 2. Next shell we can give how many? 8. So we are giving 8. We still have one more shell. One more electron is left, so we have to give one more shell, and in that shell we'll give one more electron. Finish? Now, if it wants to have an octet, which is much easier this time, you can see. If it loses one electron, it will have an octet. But you may ask, sir, it may gain also. If it gains, it will have 2. That would make it a duplet? No. It will be duplet only when the last shell is the first shell itself. In the previous case, we saw that lithium, the last shell, after losing the electron, last shell became the first shell itself. Here you see the last shell is the third shell. In the third shell, 2 is not stable. 2 is not a duplet. 2 is a duplet only if there is the first shell only. Rest of them all want 8. Okay. So if I want to make it stable, if it is not the first shell, any other shell would think of making it 8. But if I want to make it 8 here, the sodium, then what I have to do is, I have to give it 7 more, which is very difficult, highly unlikely. So it is easier for it to lose just 1. So it will lose just 1, and then after losing that, it will have an octet, as you can see here. Now it has an octet, and I have written a plus on top. This is actually Na plus. Why plus? Because it has lost 1 electron. If it loses 1 electron, it becomes a basic radical. Not only 1 electron. If it loses electron, it becomes a basic radical. It can also be known as a cation. Okay, cation. C-A-T-I-O-N. Cation. Basic radical. Okay. And what is its valency? How many it lost? 1. So valency is plus 1. As you can see here, plus. We have not written the 1, but simply plus means plus 1. Sir, will it be always plus 1? No, no, no. It will not always be plus 1. Had we taken the example of magnesium, magnesium has 12. Okay? Magnesium has 12 atomic number, which means proton 12, electron also 12. So again, if you arrange the electrons around the nucleus, we'll have first shell 2, as we can give only maximum 2, second shell 8, we can give maximum 8, and then after 2 and 8, how many done? 10, right? 2 more left. So in the last shell, we would have 2. Again, just like sodium, it would lose. It would lose, but this time how many? 2. In order to become an octet, 8 in the last shell, it will lose 2. So it will become, after losing, it will become Mg2 plus. Instead of being just plus, it will be Mg2 plus after losing the last shell, means 2 electrons from the last shell. Okay, so that's how it becomes a basic radical, by losing, and it has plus 2. This time the valency is plus 2, and it is since it is plus, it is basic radical, which means it is losing electrons. But I have shown so far only about losing. Will it not gain? It will gain also. Let's see some examples of gaining, when it is easier to gain. For example, say chlorine. Another example, let's take oxygen. Okay, the atomic number of chlorine is 17 and that of oxygen is 8. This time I am writing the electronic configuration. Means without drawing, I am writing how many electrons will be in the each shell. Each shell, how many will be there? I'm just writing and showing. First shell we can give how many? Only 2. So we're giving 2. Second shell we can give how many? 8. So we're giving 8. How many are left? How many are left? 7, right? 2 and 8, 10. So 7. Here, if I do the electronic configuration, that means arranging of electrons. 8 means first shell 2, second shell we can give 8, but we don't have 8. 2 are gone from there. That means what? We have got 6 only. 6. Now you see, it is easier for it to gain and become an octet. It needs how many? It needs to gain only 1. So if it gains 1, it will become an octet. That means 8 in the last shell. This one also, if it gains 2, it will become an octet. Is it not? So what will these two do? These two will gain. So when they gain, they become anions. This will have 2, 8, 8. One more electron increased. Okay, so it has become an octet. And why the minus? Whenever electron is gained, it's minus. Same thing with oxygen here. Oxygen will become O2 minus. Okay, 2, 8. How 8? 2 electrons it gained. So it is become both of them have become anions, also known as acid radicals. Remember this, okay? They are anions or acid radicals. Acid radicals, fine. anions or acid radicals. Now, what we need to do is, right now I have not explained in depth, okay? I have just talked to you about the basic term of valency, which is either lost or gained. Here you can see the number of electrons lost or gained. So you can see here Cl minus, there is only one electron gained, so valency is -1. Here 2 electrons are gained, valency is -2. Okay, so valency is basically the number of electrons lost or gained. Okay, lost or gained when an atom tries to have an stable electronic configuration, which means either duplet or octet. And in order to attain that, it will lose. In order to have an octet or duplet, it will either lose or gain. So if it loses, it becomes a basic radical. If it gains, it becomes an acid radical. Okay. Now we have not talked about these things in details right now because that is the concern of chapter 4. But here in chapter 3, what you need to remember is the terms acid radical, which means negative. As you can see on the top, it is negative. And you need to remember the term basic radical, which means on the top you will see a positive sign. And the valency. Valency is basically the number, how much positive is there or how much negative. Here you can see -2, that's the valency, -2. Here is the valency, how much is? Cl is minus, so -1 is the valency. Okay. If I write something like, say, Ca2 plus, then the valency is +2. It's what radical? It's a basic radical. Whenever you see plus, it means a basic radical. Whenever you see minus, it means a acid radical. Okay. And valency is the number attached to the plus, basically. If there's no number, simply minus, as you can see, that means -1. If there is a number, you can see it means -2, or in this case it means +2. So these you have to remember now. In depth is there in again chapter 4 about discussion about valency. But for now what you need to remember is, let me just finish it off with recalling the terms that we have understood today. Valency, which means number of electrons gained or lost in order to have stable electronic configuration. Okay, it can be either duplet or an octet. That means in order to have 2 in the last shell or 8 in the last shell. And when it is losing, it is becoming a basic radical. Whenever an atom is losing electrons, it's becoming a basic radical. And whenever it is gaining, it will become an acid radical with having a negative charge. Remember, acid radical will have a negative charge, basic radical will have a positive charge. Okay. So in the next class we'll discuss more about this. Today your task is to remember first of all do the task that is we have given here today, and then go and recall the atomic numbers and mass numbers, chapter 4, which we have discussed earlier. Even in class 7 you have had. So atomic number, mass number you have to learn, and go through the valency chart as well. Lot of tasks here to remember, to learn. Okay. So thank you. See you next day.